All right, let's go ahead and finish up threads. Yeah, we have a couple things. If you're back in the process land and you fork a process that has multiple threads, does it duplicate only the calling thread or all the threads? Trick question.
Why would it duplicate a thread?
Well,
True. Only the calling thread does it fork.
right, there you go. It only forks the calling thread. Yeah, the question, if I can get back to the picture. There. If we're over here, and let's say that thread calls fork, is it going to copy these two threads? No, it's only going to copy his thread, his stack, his register, and everything he's sharing. That's correct. Only the calling thread is forked. So you can cancel it. Asynchronous basically signal to the thread to die, and deferred cancellation allows the target to periodically check. So the second one is you usually have a flag, and the thread's constantly checking that flag of when it needs to exit. That's a common way to go about it. Otherwise, you can wait for the thread to send a signal to the thread, and it just dies. Either way is fine. So signal handling, this is to be able to send a signal. This is a seg fault, terminate, etc. You okay, Matt?
Just chilly.
Just chilly. All right, thread pools. One way this works out is a web server or whatnot may make a pool of 100 threads, and then when it has a task, it just assigns it to the thread and then moves on. Point one, usually slightly faster to service a request because you don't have to create a thread, the thread already exists. As you just saw from our example, that performance improvement is diminishing quickly. Creating a thread is becoming cheaper and cheaper. You can bound the number of threads. For example, now that one still is good because as we saw here, 4,000 threads was not improving performance. 40 was probably still a good number, even though theoretically 4 should have been fine on my machine. And you don't have to destroy and create a new thread. There is, again, a small performance hit for doing that, but not as much as it used to be. Thread for specific data, I mean, it has its own copy of the, right. It's a mini process. Scheduler, we're going to talk more about scheduling later, so I don't think we need to say anything here. Okay, threads. Here we go. There are actually different types of threads in Windows. Your executive thread, which then has its kernel thread, and then your user space thread. This is all one thread, by the way. It's just how it's mapped out in memory. Executive has a bunch of the, pointer to the parent process where the thread starts. The kernel thread has scheduling information, maybe something about the kernel stack if it's executing there. And then the actual thread will have the identifier, user stack, and any local storage. In Linux, you can tell a thread if you want to share things or not. So you want to share the file system with everyone else or not. You want to share the same memory space. You can actually tell the thread to have different memory space, but you're going to have to reallocate all the memory. Signal handlers are shared. You want to have the same signal handlers. Do you want to behave the same way as another thread receives a seg, abort, or whatnot, and then you can clone your files. There's a lot of configuration you can have. So pthreads, I just showed you pthreads, so I don't think I even need to go in here. We did an example. XP threads are a little more complicated, but will eventually do the same thing. The big difference with Linux threads is that Linux actually does not exactly distinguish between a thread and a process. It's just how it's created. So a thread is really just a process with all the shared memory shared. So it just it really just creates another process and then maps everything with shared memory and calls it a thread, which works out the same way. Java threads, if we had time, we'd go through. Oh, we're not doing that. Okay. Next time, we'll go through Java threads real quick. It's nice to see how it's done, but they have their own thread interface and mechanism. And the idea is that the operating system will implement the Java thread, but Java has its own API for threads. So it's a user space thread. All right, any question about threads? Is that too complicated?
I'll have to go over the code thing.
The code? All right, I will commit the code.
Yay.
Let me go do that right now while everyone is watching.
Don't forget to add the homework,
To Blackboard.
the blackboard.
Yes. I have a question. Are you copying and pasting your homework when you do your homework? Because homework number 2, the very first line says, answer these questions from chapter 1. And it's actually from chapter 2. So I haven't looked at homework 3 yet. But the first line, it says, you can answer these questions from chapter 1. I'm like, well, no, you can't.
From chapter 3 of your book. So I'm at least doing it in chapter 3.
Okay.
I'll go look at chapter 2.
It said chapter 1.
I'll go look at that. Any other questions? Nope.
What's the answer to number 1?
Got it.
Any others?